teed off into the boiler, the crucible pressure regulator, and I think you went over kind of initial setup and how you adjust these. So from this point, the boiler goes off of this line here into the machine, and this will be the same even if it's an above bar unit. You just won't have to hook it up to the back. It'll already be hooked up. It should just have these sticking out of the bottom and just hook them to the appropriate part on the pressure regulator box. So boiler goes in through, and this is the same on all the machines, whether it's above bar, mod, etc. It'll go into the boiler feed, from the boiler feed solenoid into the back of the boiler. Now off the back of the boiler is also the drain line. So, and that's the same on all the machines. Just going to be located slightly different depending on where it is. Above bar 4 actually has it going eventually plumbing to the main drain for the machine. Being that there's no drains on this, the drains are on the arches, we don't have a way of plumbing to that. So just make sure if you're draining a boiler too, it comes with extra tubing labeled boiler drain, and always keep that, use high temp tubing. If you use something else, it's eventually, you might get away with it for about 5 minutes, and then it'll probably blow it out and start shooting steam everywhere, and that's the last thing you want. So always use high temp tubing to plug into these things when you're draining the boilers, if you're draining while it's hot. If you wait until the whole thing is completely cold and you give it a couple hours, whatever, you know, a PEX or vinyl tubing will be fine, I guess. But I would always just suggest using the tubing when it comes to it. So from that point, boiler fills up the boiler through the solenoid here. If you go around to the back side, on the back side here, we have the hot water out is at the bottom left on the boiler, and it's pretty much always laid out this way. That goes into our T right here, and this T is basically where the hot and cold water meet. So on the other side of this T, we have from the crucible pressure regulator goes all the way through over to this solenoid. So that solenoid opens whenever one of these, anytime you press a fill button and we want water in there, this will open, allow cold water through to mix with hot water from the boiler at this T right here. So that's one of the reasons, if you're ever wondering why we need the pressure regulator, this and that, is because we're using such a large quantity of water compared to like a traditional espresso machine or something like that. And so the quickest way basically to get 12 ounces of water at the temperature we want is by mixing cold water coming in with boiler water. And so we do that here. So this allows cold water to mix in with this hot water. Now this boiler's at 275 degrees to 265 depending on the machine. And that's going to be anywhere from about 35 to 39 psi of pressure that's just naturally always going to be at, and that's a constant because of the temperature in this boiler. So that's why you need at least 40 to 60 depending on the machine setup and like where you're getting your machine dialed into of cold water to meet with this to mix properly to get it to the right temperature. So if it's too low, the pressure on this is just going to always win out. It's just going to keep coming in too hot. So that kind of hopefully explains why you'll get improper behavior in there and stuff like that if you don't have enough pressure going to the machine. So from this point, it goes from this T up to the warm water solenoids or hot water solenoids, depending on what documentation you read. And you can see over here, it's just a manifold. Exact same solenoids. These are the exact same components. It's just the base is in a different shape, basically. So they're all connected to a manifold on the 4 crucible versions, but exact same components on the insides and everything. So from that point, it goes from there, doses hot water through the flow meters. From the flow meters, it's just T's off of here, so it passes right through up to the crucible. So that's where you get your dosing until the flow meter. There's just an impeller in there with a little magnet. Every time the magnet goes around one time, it passes a Hall effect sensor. And it's something like, I think, 7 times, or considers it 14 edges because it measures the hit and the pass, is, I believe, approximately 1 ounce. That's what the programming is. If you're ever looking on the switchboard and you hit that and you just see numbers going on the flow meter, as a visual reference, if you do that and then stop, you can divide it by 14, measure out if you need to do a check to see if something's off or whatever. It should be approximately about 14 per ounce, approximately anyway. It's 14 or 7 now, can't remember. You'll probably know pretty quick. And then at that point, Once that is counted through, these are the steam solenoids. So anytime you're facing your kind of manifold here, it's always hot on the right, flow meters in the middle, steam on the left. Same over there. You can see it's just the same solenoid bank, kind of same deal though. Steam on there on the left. So then what happens is these are going to kick on. This whole line is filled with water, which is not compressible. This is closed, so basically from here out to there is its only path of movement because there's an open end at the crucible. So that way we don't send steam back this way, always pushes out that way towards the crucible. So from here, steam solenoid's open. If you trace back the feed on those go to the top of the boiler back here. So that's the steam outlet, hot water outlet. So boiler's pretty straightforward as far as inlet on the opposite side, outlets there. Only exception is going to be on the 2-group above bar boiler. We have documentation and stuff like that. If you guys are ordering one of those machines, you can see where those components are laid out, and it's still pretty easy to figure out. The arrangement's just a little different. But, so from that point, it just goes up to the crucible, and that's where steam pushes into the bottom portion of the chamber there to heat up the water and create pressure to push it up to the top and heat up the water, which you guys should be pretty familiar with at this point. So that's pretty much it for water flow inside of the machine. You guys have any questions on any of that at all? All right. Next thing then, this thing's on and up and running. This will be a little more in depth. We'll get into the electrical. So basically, you know, you can order the machine 1, 2, 3, 4 crucible, but they're basically, as far as the electrical, split into 2 categories, the big and the small. So it's 2 crucible or 4 crucible. And that's basically the heating element that's in here is the biggest difference between the two, as well as the AC to DC converter. It's a 75 watt DC output on the 2 crucible, 120 watt for the 4 crucible. And that's because there's some extra actuators that count in those things. As far as DC output, those use the most on the machine for the most part. So power in, multimeter is definitely your best friend. This one, for most things, you won't need one like this where it has the clamp for measuring amperage. The one that I think he showed you before, like our Radio Shack ones, is kind of our standard that we teach people with. That one just ran out of batteries, so I'm going to use this to show you. But honestly, this is probably one of the best pieces of equipment for determining, you know, if there's something wrong as far as the functionality of the machine, you think it could be traced to an electrical thing, these are super handy. Now, of course, anytime you're doing this kind of stuff, you want to be very careful because anytime we're doing maintenance on the machine, first thing you generally do, unplug it, turn off the power. Obviously, if we're measuring power, the machine needs to be running. So this is something, if you're not comfortable with it, get an electrician to do this and just know, okay, here it should be reading this, here it should be reading this. So I don't want anyone doing anything with electrical stuff that they're not comfortable with. But I'm still going to go over it so you guys know, you know, what different components you're supposed to be getting, what kind of power and how much power and where. And kind of troubleshooting stuff like, if this, check that, etc. So generally anytime something's not working electrically, measure at it and start working back as far as like the components that it's attached to and what's controlling it. So we'll just start as far as power in and go through how it's all connected. So basically you have 220 or you know, anywhere from 208 to 240, basically depending on where you are in the world and how the machine is set up is going to be coming in through the power line. Now it should always probably be a 3-wire system. In the US we call it single phase, but it's not. Just it's actually 2-phase that are opposite each other and a ground. So in the US, the electrician will call it single phase, and 2-phase, they get confused, and talk to anyone internationally, they get confused. So anyway, it'll be the black and the white are going to be your 2-phase lines. So it should be 120 on each of those. You can kind of check here. If I do this, you can see between the black, and then we can use the ground as the reference. Come on. This thing sometimes takes 2 tries, that's why I like my other one better for measuring voltage. Oh, I'm on DC. That would explain it. So, between that one and the ground, I get 123. Between the other line right over here and ground, I get 123, or 120. Now between the 2 phases, that's how you get the 240. So that's how it works in the US. If you're out of the country, it's going to be a 220 phase line, so all the voltage through one, a neutral line, and a ground line. Now if you're doing that, you just gotta always make sure the black wire right here on the back side of this contactor, even if you change out your entire plug, an electrician may do that. They may come in and they don't like this wire for whatever reason. They'll take out the whole wire, put in a new wire. I've seen that happen lots of times, and it kind of just depends on the electrician. But you just got to always know if you're working outside of the U.S. Or North America. I think I have to do more research into like Central South America. But outside of the U.S., the red line is going to be your phase. So that's going to be your 220 line. The black is your neutral, and the green is always ground. So, and in the US, hot, ground. So, pretty easy. And if, it's not a huge deal if they hook it up wrong, as long as they hook the ground up correctly. That's the really important one. If they hook the other two up wrong, basically the heating element just won't turn on, and the other components will turn on possibly, and you may be confused why the machine's not heating up. That's kind of the first thing to check. If heating element's not turned up, okay, is the power right? Because basically one of these lines goes through a solid state relay, the neutral line goes right to the heating element, and so if you flip them, solid state relays can't turn on and off a neutral line. They can only turn on and off the power line. They basically need that back power to be able to turn on and off. So from here, you can see it gets split off, and this is hot, so I gotta be careful what I'm touching here. So we have two lines coming off of this, and also if you're international, you may not see this component. You'll see a little silver box. It's an electrical filter. So that's just different standards for different, a CE, CB standard versus a North America standard. They kind of require different things. They both have pluses and minuses. But as a heads up, if you are ordering from outside of the US, it may not have that. It'll be a little silver box, but same thing. 3 wires going in one side, 3 coming out the back side. And then from this point, they get split. So 2 wires, the 2 hots, or hot and neutral, go to the contactor. The other 2 go right to the AC to DC converter, which if you guys all come around, you can kind of look under. It's the silver-sided box there in the middle. So this is always the electrical panel, and there you go. So this is, and all of them are always laid out this way, no matter what machine you order. It's going to be the contactor, which is basically a big on and off switch. When you turn the machine on, that's the click you're hearing. Then this is the AC to DC power supply. Most electricians, you'll hear just people call it a power supply. And then this is the level meter box over here. So this is what controls the level and fill meter on the boiler. So they're always laid out left to right in the same way, no matter what machine. Thank you. So as soon as